All right. Yes.
This, do we have to take notes into the questions?
I don't. No, you don't have to take notes. I did it on chapter 1 because that was an intro chapter. I think there's one other chapter I have you take notes on, but other than that, we'll either be doing questions at the end of the chapter or I'll have a packet of questions. So, no, you don't have to take notes. That's a great question. Everybody hear that?
Yes. No notes.
Okay. Not unless I tell you. All right, let's take a look. So the handout sheet I want to give you, we start out a little differently because I started out with this chart. I'm going to wait till everybody's ready, okay? Everybody ready? Now, this chart, they have a small version of this in the book, but they don't emphasize this chart. Yes?
I don't have that. I lost mine.
Okay. Okay.
Will, I
Okay.
can't believe it.
All right. All right, gotcha. Come up here, Will. You're on this table. At the end of this table, there's one. Okay. Here we go. Now, I put more emphasis on this chart than the book does because if you can learn this chart, then the stuff that we did with metric to metric conversion, that makes a lot of sense. And then you did scientific notation. Yeah, right there. We did scientific notation, and that makes a lot of sense. And that's really what I like when I teach science. When I want to have a science student be better than a lot of other science students, I think this works. Like, for example, if I were to write this, if I were to write that, I don't want any science student that I have, I don't want them to be nervous about that. You should be able to look at that and say, hey, that's a metric. Oh, so what? I'm okay with that. Hey, what is that number there? What's 3.5 times 10 to the minus 6? And I know it's Monday. I know it's a Monday.
0 point something.
I know, but what is it in regular words? 3.5 what?
10. Oh.
Thousands.
10.
Million.
Millions. It's 3.5 millionths of a gram. And that's really, that'll go a long way. If you become a science major, if you go to school and maybe go to college and you're thinking about doing things that are science related, you don't want this kind of stuff to stand in your way. And so that's why I spent a little time with this because it makes the other things a lot easier. Now what I want to do is, in your book, let's talk about this page here. It's your job to at least, the minimum is to scan the chapter. You get that? Scanning it, you look for pictures. You might read the captions on a picture, or you might look at the dark print words. So let's take a look at this. When we do a thing, this whole chapter is on measurement. And measurement, we're going to find out in a minute, everything you measure has three things in common with everything else you measure. And if you're in my STEM class, don't answer this question, but do you know that every measurement has three things in common with every other measurement? No matter what you measure, there are three things they have in common. Have you ever heard of that? What would you say? What's something that every measurement has? Like here's a measurement. The amount, okay, so it has a number. So every measurement has a number. All right, what's next? I'm going to see if the people not in the STEM class, if they can come up with it. Yes. A unit. Okay, it has a unit. And this is something we're going to find out in this chapter. And maybe I wouldn't do this in elementary school. In middle school, maybe I'd think about it. But certainly in the 10th grade, I would do this. Every measurement has this also in common with every other measurement. Every measurement has error. Now, nobody likes that because error sounds like a bad thing, but error is something you have to live with. If I have a certain kind of a ruler and I only paid so much money for it, it can only give me a measurement that's good enough for that ruler that I paid for. And yet, you have a clock, you have a watch on your phone, a clock. It probably goes to hundredths of a second. And you think, wow, that's really accurate, or that's really something. And yet, I was hearing about some atomic clocks that are going to millionths or 10 millionths of a second. Now, you and I don't need that kind of a clock, but somebody doing research, they need that kind of clock. And so your clock has error. even the clock that goes to a millionth of a second, there might be some scientist said, if I could only measure hundredths of a millionth of a second, I could do this experiment. And that's what they're doing. And that's what technology drives, many times, technology drives scientific discovery. Right now, I know they would like to be able to make computer memory not in a chip form, because a chip still fits through the eye of a needle, but a chip is still too big. As small as it is, it's still big. Scientists would like to be able to store memory at the atomic level. And that means, can I design something and push the atoms around to make a computer chip at the atomic level? Well, then that little chip that we have today, that would be a million atomic chips. And all of a sudden, you could put a huge amount of computing power in a very small amount of space. But right now, we can't do it because measurement. Right now, we don't know how to measure well enough and we have to be able to manipulate atoms. That's another thing. That's technology. But technology will come along. And you'll see us, in your lifetime, you probably will see atomic memory. Memory at the atomic level or the molecular level. And that'll be a big breakthrough. All right, so anyway, we have to live with this. Now, you'll find out later in this chapter that when they say this number, we're going to talk about this thing. They're called significant figures, and we'll talk about that in here. And the units, we already know a little about units, don't we? So I'm okay with that. I do want to show you one thing, and I'm not going to emphasize this. Here's a handout sheet. I would emphasize this in physics class, or my advanced chemistry I do, but this right here is something you probably don't have to learn. I do want to show you one other thing, but over here in this column right here, 1, 2, 3, 4, 5, 6, 7. There are 7 what they call base units, and that's where they come in here. See the word units right there. And then they go down here, they say the English system. And the English system is actually, England doesn't even use it itself, right? It's called the English system, and they don't use it. But anyway, they changed over, this was around 1800 when it started, but countries didn't buy into it right away. But certainly now, today, U.S. and Burma, the only 2 countries that don't exclusively use a metric system. Now, I will tell you that in around 1960, something happened where the scientists said the metric system was nice, but we discovered so many new things, it's a little bit awkward. And so what they did is they modernized it. They modernized the metric system, and they called it the SI. And that's not Sports Illustrated, but it stands for we say the international system. But if you know any other language, like French, anybody know French in here? Okay, like if you want to say the red pencil in French, you say le crayon rouge. And they would say the pencil that's red. How do you say it in Spanish? The
Rojo lapis.
Which order do you say it?
Lapis rojo.
Oh, that's it. So in almost every language, they put the adjective after, right? That's why it's called the SI system, the System International. So now, the modernized version of the metric system is called the SI system, and that's what this is. And what they did, and I'm not going to spend very much time with this, they said there were 7 base units. And what that means is, if you want to measure anything from now on, you have to make a definition in terms of these 7 things. Like, the word leader is not even on here. We need to measure liters, but it's not even on here. Why? Because if you take a meter stick, and meter's on here, isn't it? Is meter one of the base units? All right, so here's a base unit for mass, the kilogram. Here's one for length, the meter. Here's one for time, the second. I got these. You don't know this. We'll spend a lot of time with this in the second semester. The mole is the number of particles. Next is the ampere. That has to do with electrical current. And then here is temperature, Kelvin. We'll talk about this chapter. And then there was the candela, which has to do with light. And we won't be talking about that at all. So here's a meter stick, right? And what's a tenth of a meter called? And you're supposed to know your prefixes. What's a tenth of a meter? Say it again. Not deca. Decimeter, right. Okay, now, so there takes 10 of those, right? This is a decimeter. And if I go over here, look at this one. It takes 100 of these things. So what's 100th of a meter called? What's 100th of a meter?
Centimeter.
All right, these are centimeters. And then if I, the little tiny lines, if I use the little tiny lines, there are actually 1,000 of those spaces here. And what's 1,000th of a meter?
Millimeter.
Okay, so that's what this stick's all about here. Now, why am I showing this to you? I want to show you that I need to have the word liter. The liter was in the metric system, but the modernized version, the SI system, doesn't have it in there. It's not because you don't need it. It's because they figured out with those 7 units, you can define everything else. Now, for example, see this guy right here? See this meter stick? If I take 1/10 of a meter, that's what I did. If I take 1/10 of a meter, hang on. I bet it's frozen. Okay, so if I take 1/10 of a meter and I build a side of a cube here, and I take 1/10 of a meter long and 1/10 of a meter wide, 1/10 of a meter high, I have myself a box called a cubic decimeter. It's a decimeter times a decimeter times a decimeter. And that's 1 decimeter to the 3rd power, 1 cubic decimeter. That's what they call it. This is called a 1 cubic decimeter of volume. And you know that is a liter. And so I don't have to have the separate thing liter because I can define it in terms of the meter stick. Get that? So if you look over here, why don't I have a definition for speed? I use speed all the time in physics. Why don't I have that over here? Well, because if you look, speed can be, if you take meters and seconds, meters per second, there you go. There's your unit for speed in the SI unit. Everybody get that? So that I just wanted to touch on that. I'm not going to have you memorize the chart or anything like that. But even your book talks about the 7 base units in there. They're right here on this page, on the very next page. And these are your base units right there. Okay, I'm sorry. These are the base units right here. Anyway, so let's go on to the next page, and I want to show you what we're looking at here. This right here, this box, I'm gonna show you everything I know about this box, okay? And this box is kind of big. Every good science student knows this box pretty well. So I'm gonna start with this box, and we're gonna build it. I'm gonna show you how to draw it. So if you have notebook paper or something like that, or if you can draw it, I'll tell you what, you could even go right here and just take notes right on that little piece of paper right there. All right, so let's take a look at this box. And I'm going to draw it right here. And what do we know about this box? Even though I have flat paper, it's called 2-dimensionality. I'm trying to represent a 3-dimensional object on here. So it is a cube, isn't it?
Yeah.
So how do you find the volume of an object that has 90-degree angles? How do you find the volume of something that has 90-degree angles? This is math stuff. Length times width times height. Okay, now, I'll tell you, I know what you're thinking. You're thinking, you memorize all these. No, that right there, I knew that, right? But what do you know about this liter? What do you know about this liter box? And I know that for the first time ever, when they made the metric system, they did something nobody in history had ever done. Once they had this stick, they said, I'm going to build something to measure volume with this stick. How can you do that? The stick measures 1-dimensionality. Well, we'll make a cube out of it. Okay, this big? Are you going to make it the size this big and this long? And that could have been the liter box, couldn't it? But no one would have used it. Why? Everybody look at me, okay? Why would they not want to use a box this long, that wide? Hey, let's fill that with wine. Let's fill that with, it was in France that did it. Who's going to use that box? Nobody. So, well, I get it. Why don't you just kind of make it like half that size? Nope. Okay, that's dumb. You can't, if you don't want to use a meter, what's your next choice as long as you stay in powers of 10? What is it? If you're not going to use a meter, what's the next smallest? It's staying with powers of 10. That's a decimeter. Okay. And that's what they did. They honestly built a volume container from this. There is no way your yardstick has anything to do with a gallon, is there? And you say, of course not. But here, of course it is. And so what they did is they purposely made this 1/10 of a meter long and 1/10 of a meter wide and 1/10 of a meter high. Now you know, watch this now. Let's see if you know your prefixes. You know that 1/10 of a meter is how many decimeters? 1/10 of a meter equals how many decimeters? 1 decimeter. Okay? 1 decimeter wide. 1 decimeter long. Okay? What's the next? Tell me about centimeters. How many centimeters long is that box? Notice as the unit gets smaller, see that? As the unit gets 10 times smaller, what happens to the number? It gets 10 times bigger. What goes here? What goes with centimeters?
10.
Okay. All right, 10 centimeters. Centimeters about with your little finger. 10 centimeters, 10 centimeters, 10 centimeters. Okay, let's go down a little bit longer, a little bit further. What's how many millimeters across is this box?
100.
And now you caught on to the pattern. You see why I spent time with that chart? It makes so much sense. Okay, now let's that's far enough for right now. So now you could tell me many ways to represent this box. You could say the box is 1 liter. Fine. What else could you tell me? How about 0.1 meters times 0.1 meters times 0.1 meters. Ooh, who can do that in their head? And I know you don't want to do it in your head, so I'm going to show you what you should be able to do. It's Monday, I understand that. But isn't this 10 to the minus 1? 10 to the minus 1 times 10 to the minus 1 times 10 to the minus 1 is what? 10 to the negative third. And what's a meter times a meter times a meter?
3 meters.
So you could write it as 0.001. Wow, I understand that. That's from that chart. So this box is not a cubic meter. By the way, what does a cubic meter look like? It's a cube. And it's this big along, and it's that wide, and it's that tall. That's a cubic meter. It's volume, isn't it? Is this a cubic meter?
No.
But is it what? How much? 1/1000th of a cubic meter. What? How many of these would fit in a cubic meter then? 1,000? No way. Yes way. 10 along this way. 10 along that way. How many on the bottom floor? 100. And how many floors? That's 1,000. This is 1/1000th of a what? Not meter. Meter's not volume. Cubic meter. Now let's go to the next one. So I know that that's a liter. Give me another one. And I don't memorize these. I'm just doing the math, aren't I? What's 10 centimeters times 10 centimeters times 10 centimeters? Let's do that. Well, that's 10 to the first times 10 to the first times 10 to the first. What's that?
10 to the third.
This box is also 1,000 cubic centimeters. 1,000 cubic centimeters. Now, because the people who did the metric system, because they had time to think about this, I thought it was ingenious that they connected this to this. I thought it was also ingenious that they did this. 1,000 cubic centimeters is also the same as 1,000 milliliters. A milliliter and a cubic centimeter are the same amount of volume. Okay, let's go on down. And what's 1 decimeter? Is it time to go? Okay, what's 1 decimeter times 1 decimeter times 1 decimeter?
Decimeter cubed.
And that's what he called this. This is a cubic decimeter, isn't it? Isn't that right? All right, listen, go ahead and work on your homework a little bit tonight, and, give me about 15 minutes every 2 nights, right? Something like that.